A liquid is in equilibrium with its vapor at a certain temperature if delta H for the vaporization process is 60.24 kilojoule per mole and delta S for vaporization is equal to 150.6 joule per mole, then the boiling point of the liquid will be. So in this particular case, we should know that the process is in equilibrium. It is in equilibrium with the vapor. It means the liquid that we have is in equilibrium with its vapor and the temperature is also fixed. Enthalpy of vaporization is given. Entropy of vaporization is also given. So one thing we should know that whenever we talk about the relation of delta H and delta S, we can compare it with delta G is equals to delta H minus T delta S. And here the process of vaporization is taking place. Now, this delta G value is 0 because we are talking about equilibrium. Now, if this value is 0, it means delta H is equal to T delta S value. Delta H value we already have. Delta S value is also there. So we just have to find out that temperature at which these two states coexist, and that is the boiling point of that liquid. So the C value is equal to delta H upon delta S. And what is the value of delta H here? Delta H for the vaporization, that is 60.24 kilojoule per mole. Let's change it into joule per mole. So this is the value. Further it's divided by delta S value, and that's also given 150.6 joule per mole. 150.6 joule per mole. And if you solve this, you will find out that this is equal to 400 Kelvin. It means this is the temperature at which these two states coexist, and that is the boiling point of that liquid also. Option 4 is the correct answer that you can choose here. Further, let's take question number 72. Question number 72. For which of the following processes entropy change is negative? It means we have to just find out that process for which entropy change is negative. We should always know that entropy change is positive when the system becomes more disordered. But we need here the entropy change as negative. It means we need the process in which the system is getting ordered. Let's check the options given here. If we talk about evaporation of water means we have liquid water and that's get changed into water in gaseous state. It means more randomness is there, more disorderness is there, and that's why in this case delta S value is positive, not negative. Further, sublimation of camphor, it means camphor you have, it is solid, getting changed into camphor in vapor form, more disordered, and again entropy change is positive. Condensation of iodine vapors, it means iodine vapors are there and these get condensed to form iodine solid. What will happen in this case? More order is there, less randomness is there, and that's why entropy change for this case would be negative. And if we talk about melting of ice, it means ice is there and it is getting changed into liquid. There also entropy is increasing. But in case of condensation of iodine vapor, there is delta S value that is negative. So answer you can easily choose for this question is option 3 that's given here. And now it's a turn for next question. Question number 73. Unit of surface tension is. In this case, we should know that surface tension is force acting per unit length. What does it mean? It means surface tension is equals to F by L, and the unit of the force is Newton, while the unit of length is meter. So this would be Newton per meter or Newton meter inverse. This is the unit for the surface tension, and that's why which option is the correct option? This is given in question 3. And that's why this option 3 is the correct option for this particular question. Let's take the next question. Question number 74. If 200 ml of 0.1 molar H2SO4 solution is mixed with 200 ml of 0.15 molar NaOH solution, then heat evolved during the neutralization process is. What's the process that's going on here? We have H2SO4. It is mixed with sodium hydroxide. This is the neutralization process, and during this process there is the formation of Na2SO4 and H2O. Along with that, heat is released, and in this case you just want to find out the heat of neutralization. Here we have the different quantities given. 200 ml of 0.1 molar H2SO4 is given, and 200 ml of 0.15 molar NaOH is also given. First we'll find out the milli equivalent of these two substances. So what would be the milli equivalence of H2SO4? Just find it out. 200 ml is the volume, and what is the normality here? We have molarity, that is 0.1. I'll just multiply n factor to it, and ultimately it would be 40 milli equivalents. Now, milli equivalent for NaOH would be normality. You can find out that would be 0.15 into n factor, that is 1. So, normality is 0.15, and what is the volume? 200 ml. It means, in this case, 30 milli equivalents are there. Now, how many milli equivalents would be utilized during this process? Definitely 30 milli equivalent. So, what would be the value of equivalents? It would be 30 into 10 raised to the power minus 3. Now, let's find out the heat of neutralization. We know that heat of neutralization for a strong acid, that is H2SO4, and a strong base, that is NaOH, is equal to 13.7 kilocalorie per equivalent. So how many equivalents we have? We have 13 to 10 raised to the power minus 3 equivalent, because milli equivalents are 30, that's why equivalents are 13 to 10 raised to the power minus 3. So heat released during given process is equal to 13.7 kilocalorie. Let's change it into calorie into the equivalent. Those are 30 into 10 raised to the power minus 3. And if you solve this for the value of heat released, you will find out it is 411 calorie. Where this answer is given? It's given in option 1. So you can easily choose option 1 as the correct option. Let's take question number 75. Now question number 75. Which among the following will boil at highest temperature? We have different options given here. We should always know that more the molecular attraction, more would be the boiling point. It means the liquid with more molecular attraction will boil at highest temperature. So if we talk about HCl, HF, HI and HBr, this HF includes intermolecular hydrogen bonding at a very large extent, and that is why in this case the more molecular attractions are there. It means if you're comparing all these species, this HF has the maximum molecular interactions, and that is why it has highest boiling point. And if it is so, we can easily choose it as the correct answer. That is option 2. Let's take next question.